I spent the last 7 days printing non-stop with nylon carbon fiber on the new Bambu H2D, and the results have been insane. I've got over 9 prints to show you guys in today's video, and I also used ABS and ASA for supports for some of these prints. And let's just say the results were not what I was expecting.
I do also want to mention that this filament was dried using my poly dryer on the highest setting for 24 hours.
So what even is nylon carbon fiber? It's also known as PA6-CF. It's a tough, heat-resistant engineering material reinforced with chopped carbon fiber. It's super strong, stiff, and very lightweight, making it perfect for functional parts and high-load applications. It costs around $80 per kilogram and requires serious printing conditions for good results. We're talking a 275-degree nozzle, a 100-degree bed, and a 60-degree chamber temperature for optimal printing. But that also means that it's a pain to print, especially without the right setup, which is exactly why I used my new H2D for this entire test. So to kick things off, how about we start with the classic torture test, the Benchy. It's simple, fast, and unforgiving. Perfect for seeing how PA6-CF handles overhangs, stringing, and detail right out of the gate.
Okay, up first we got the Benchy. This took about 1 hour to print, and it came out awesome. It's got a great matte finish on the outside, and there are virtually no artifacts. It did great on the overhang performance, had a perfectly flat first layer, and yielded one of the best benchies I've ever printed. Super, super nice benchy. Up next, we got the carabiner, the Spirabiner that I printed. I found this model for free on Bambu Studio. And when it first came off the bed, the clasp section was a little fused together, but I was able to break it apart. And as you can see, this print came out perfect. The outer surfaces look really clean, and there are no artifacts. And the top surface has a little roughness to it, but it's not too bad. Next, we have the P1S Side mounted spool holder that I designed. And I printed this because carbon fiber nylon is a perfect material for this, since it needs to be really stiff. And this thing came out awesome. It's got a perfectly flat first layer, and it has a great top surface finish as well. And overall, it looks super clean, and I'm very happy with it. Next is the Tesla Karen lock. You guys have seen this in my other video. And I love printing this print because it's a functional print and it's a part that I sell on Etsy. And it really shows off the outer surface quality that this printer can produce. And the only thing I noticed was there's a little bit of Z-wobble or horizontal banding, and it might be because of the infill. I'm not exactly sure, but I only saw it on this print, so I don't think it's anything to worry about. Then we have the print in place hinge. This was a little stiff coming off the bed, but I was able to get it to start moving really smoothly. This thing looks really great. It has a perfectly flat first layer, and it's got great range of motion. And this material would also be really good for hinges as well, considering how stiff and tough it is. So definitely a cool use for it. Oh, and I also found this model on Bambu Studio. Then we got the SD card case. I also found this on Bambu Studio for free. And this is actually a multi-material print. As you can see, the white is ABS and the black is the nylon carbon fiber. This one also has a great outer surface finish, and the ABS buckle came out really good. It doesn't have a full range of motion, so it can't flip up completely, but I mean, it looks really cool. And unfortunately, the hinge had too tight of a tolerance for this material, so it ended up breaking. And as you can see, I could just pop it right apart. But I mean, besides that, the print looked really good.
Now, up to this point, everything you've seen has been printed without supports, but I wanted to take it a step further. So I printed 4 more parts with ASA and ABS as support materials, just to see if they could handle the high heat and bonding strength of nylon carbon fiber without completely fusing together or warping into a mess. This is where things get really interesting. How about we start off with the smaller prints, the flower pots.
And I wanted to pull you guys into Bambu Studio really quick so I could show you how I set up this flower pot print with the ABS supports. So over here in the support tab, I've enabled supports and I went with manual supports because when I did the automatic supports, I was getting some artifacting. I have no idea why, but just getting artifacting on the supports and I want this to be as clean as possible. So I found that painting and going with manual supports ended up with a better result. So that's what I did. To select what material you want for supports, it's going to be right here under Filament for supports. You can select if you want the majority of this to be ABS as well as the interfacing layers. So if you only want the top like 2 or 3 layers to be printed out of the support material, then you can also select, as an example, I can go PA6 carbon fiber for the majority of the supports and then have ABS just be the interfacing layers. So as you can see, now that it's sliced, I have PA6 carbon fiber as the majority of the support, and then only for the interfacing layer do I have ABS switching in. So that is an option for you guys, but obviously I'm going to go ABS all the way because it's significantly cheaper than nylon carbon fiber. So while that loads, I'll go through the rest of this stuff. For top Z distance, I have set mine to 0. This way, the supports and the nylon layers will just butt up against each other perfectly. There's not going to be any gap, so there shouldn't be any like drooping from the overhangs. It should just be nice and clean, nice and flush. It'll look like a normal layer basically. And then I've set my top interface layers to 3. I like to set it to the max just so I have a nice solid top layer for the part to print on. And then for the top interface spacing, I have this set to 0 millimeters. So I have a nice tight layer as if it's like a normal layer basically. So this is what that looks like. So you can see it just looks like a normal layer as it's printed. So this spacing is what this controls. The support object XY distance I have set to 0.5 millimeters. Increase that just a little bit, just so I have a little bit more of a gap right here. So it's a little bit easier to take these off in the instance that these supports adhere too well to the nylon. So yeah, that's how I set up this little flower pot with the ABS supports. As you can see, I'm printing the little feet out of the ABS as well. And it's going to take 9 hours and 32 minutes. And it's going to cost about $9.
All right, guys, here is the ASA and nylon carbon fiber flower pot. Look at that. So I already snapped the feet in, but these just pop right back out. These are awesome. They're like perfectly press fit. As you can see, they just snap right in there. Got a nice friction fit. But let's go ahead and pop these supports off and see how easy or how difficult it is to separate them from the nylon. Wow. Look at that. Look at that. It just popped right off. Remember, this was 0 spacing between this layer here and the top support layer, the interface layer. And you can see that that was essentially just a solid printed layer. There's no spacing, like interface spacing in the X and Y. Look at that, guys. Awesome. And I don't know if you guys can spot that lip, but it's perfect. Really, really nice flat surface right there because of that layer. And look at how that print's looking right now. It looks beautiful. Okay, I might have to grab something to help me get this out though, maybe like some tweezers or something. And luckily I've got some handy. So now let's see how how difficult this one's going to be, because this is going to be the tough one. Just going to try to massage it out maybe. Okay, so I got this out, but you can see that bottom layer is still down there. So can I get it out? Just the question. I've got these little drain holes at the very, very bottom for the base of the pot. And it looks like the ASA has kind of keyed itself through those slots. So there we go. I can see it now. Look, I can see it now. Yeah, that's kind of, this is what I was kind of expecting. Like, so I knew that ASA wasn't gonna adhere to the nylon, but as you can see, there's a little corner right there for one of the keyed like slots. Go ahead and show you guys what that bottom layer looked like after pulling this center part out. So as you can see, it looks like a regular layer. It's actually a really nice layer. It almost looks like when you do ironing on the top layer. It's kind of how smooth it is. It's really nice. The other side. So it didn't adhere to the nylon. It's just these keys were giving me trouble. But as you guys can see, this is the finished product. Look at that. It looks so good in carbon fiber nylon. So good. That's the bottom surface down there. I don't know if I can get it better. Yeah. So that's what it looks like. It's really smooth. Maybe I can prop some of my lighting up. Looks really smooth and clean. The inside looks really good as well. It doesn't look as good as the outside probably, but most likely that's because of the supports. But came out relatively easy besides those little keys that popped right off. So that's the finished product. A little ASA and nylon flower pot with little legs. Pretty sweet, right? Before I put this to the side, I want to show you what the prime tower looks like. So I thought this was really interesting, so I saved it for you guys. So every time the nylon would switch in, as soon as the little nozzle lever would move out of the way, the nylon would start oozing out. And so these little strings, little hairs, are from basically the nozzle oozing during every switch. So it would ooze a ton, and then right before printing on the prime tower, it would just kind of drag its little hairs over the edge. So that's how you got that kind of effect. But it looks kind of funny. Looks silly. But not a huge prime tower for how big of a print this was. It's not light, it's pretty dense, but yeah. All right, and here is the ABS version. So same thing. I got the nylon carbon fiber, beautiful top surface here, and ABS supports with ABS feet. So I'm gonna go ahead and pop these ABS feet back out. Now, from what I've noticed so far with ABS and nylon, it seems like ABS just has a tiny bit more stick to nylon than ASA does in terms of the supports. So I'm expecting this to be a little bit more challenging, but we'll see right now. Okay, let's see how difficult it is to take the supports off. Okay, definitely not bad. Oh, I see. So I think these were even connected to those little drain ports. So when this guy goes up in there, yeah. So it looks like those supports are connected all the way through that drain port. Just when I pull this out, see that's right where the drain port is. So it's kind of interesting. But that's what the support looks like. Came off relatively easy. A tiny, tiny bit harder than ASA, I would say. Tiny bit. So it does have a little bit more stick. It looks fantastic, just like the last one. I actually think this top surface came out better. You compare them. Oh, no. They both came out really, really clean. This looks like up close. I hope this is still in focus for you guys. Okay, now the challenging part. Let's try to get this out. Okay, so that's that. And it looks like that little bottom layer started to pop up already, so maybe this will be easier. I have really cool picks, and not a lot of people have these, so. Alright, I've got it up. Okay, that actually seemed easier. I don't know if that's because I have had the experience of removing the last ones. That's probably what it was. But it did seem like pulling out the center supports lifted up this layer a little bit and like broke one of the tabs. So I was able to kind of remove it a little bit easier. But the same thing happened. You can see a little tab left over. So I'm gonna get my trusty poker and poke this thing through the hole and drag it back out. And voila, that's the supports removed. That's what the part looks like. And that's what the bottom layer looks like. And it came out super, super clean. So both ASA and ABS, I would say that they were pretty equal in terms of support removal. So neither of them fused or bonded too well to the nylon, which is a good thing, right? That's what you want for supports. Yeah, these pots look so good. Go ahead and snap the feet back on and we'll call it. I'm really impressed with how these guys just press fit right in. It's got a great fit. Okay, and that's my ABS foot flower pot out of nylon carbon fiber. Totally overkill.
All right, so I'm going to show you guys how I set up the bracket as well, just so you can see how good the result really was. So, I mean, check this out. I printed this 12-inch bracket on a chamfer's edge or a chamfer's face. Can you guys spot that right there? So the only thing touching the plate is this chamfer's face, and that's it. So I did apply a good amount of glue. I was pretty liberal with how much glue that I put down. And then I gave it a big brim as well, just to try to keep, it adhered to the sheet. But in terms of how I set it up, that's what it looks like. That's all I did. And I'll show you what it looks like as I slice through. So as you can see, the layer that's actually touching the print has 0 mm spacing, just like the flower pot. So you can see 0 mm right there. And the top interface layers, I went with 3 again. But yeah, super easy to set it up in the slicer. And that's what it looks like. This guy took 13 hours and 22 minutes and costs about $17.40. Just for fun, let's see how much it would cost if I went PA6 carbon fiber all the way. Okay, so as you can see, I'm saving about $3 just by going with ABS as my support material for this print. That's pretty good. I mean, I'm really happy with saving $3 on a print like this that already costs, a pretty significant amount of money. So yeah, that's how I set it up.
So after a full week of pushing nylon carbon fiber to its limits, I am seriously impressed. This filament is no joke. It's super stiff, heat resistant, and built for performance. But it can also be unforgiving if your printer isn't up to the task. Thankfully, the H2D handled everything that I threw at it. Even the 12-inch brackets that I printed on a chamfer's edge. As for the support materials, ABS, it turned out way better than I expected, and the same goes with ASA. These materials are both cheaper than nylon carbon fiber, so I would highly recommend their use as supports for this material. But let me know in the comments if you've had better luck with other combinations of materials. Maybe I can test those ones next. If you found this video helpful, please drop a like, subscribe, and hit the bell notification icon. I've got more tests and print experiments coming soon, and you do not want to miss them. All right, this has been Sam with Muxlow Makes. Thank you so much for watching.